We're going to cover 7.2 today, and I'm going to record the notes in second period because I felt like the ones that I recorded in first period didn't come out so good. So I want to be more streamlined with your class, and I'm hoping this all makes more sense to you. First thing I want you to know about Unit 7 entirely, is that geometry is more language than it is mathematics. If you learn how to write something, if you learn what something means, you will be able to pass geometry very easily. It is not like what we were doing before, where you had to learn how to do a process of things. This is more like, do I know what a shape is? Do I know how to write that shape? Do I know what this abstract idea is? So let's start off with a point. It's the first word we need to define. A point is just a location. And I know that's hard to understand, but in geometry, a point is just a place. It has no height, it has no depth, it has no width, there's no length, there's no width. It's just an exact location. Okay? We use a capital letter next to a dot or an intersection. So let me give you an example. When I look at this picture, there are lots of different points on this picture. If there's a capital letter next to a dot, it's a point. I'll give you one example. A is a point. How come? It's a capital letter next to a dot. I'm going to put a comma here. I'm going to give you one more example. There's a capital letter next to an intersection, where one line intersects with another line. And that's at a very specific point. It's at point C. Simple math, isn't it? Like, geometry is a little different. It's about knowing what the different parts are. Okay, next word. Line. Line goes on forever. In geometry, things are abstract. You are not going to necessarily be able to see a real line in real life. Not here on Earth, at least. A line in real life doesn't exist. It only exists in our minds. How many lines go on forever? No lines go on forever on Earth. When I think about these lines on the ceiling, guess what? They stop. Those are called segments, by the way, which we'll define in a second. But lines go on forever. We use 2 points and double arrow bars. Double arrow bars looks like this on top. Or one lowercase letter. A line goes on forever. We use 2 points and double arrow bars on top, or one lowercase letter. Notice there's no bar on top for that. So let me give you an example. When I look at this picture, there is a line. I want to use one line, and I'm going to say that it is line CD, and I'm going to put on top of CD double arrow bars. When I write CD with double arrow bars, what it means is it goes forever and ever in both directions. It never stops. That's the definition of a line. And that line is the same line, is equal to, is the same thing as line BC. Since CD goes forever and ever and ever in both directions, it is the same line as line BC. It doesn't matter that I'm using two different letters. The order doesn't matter. I can use this and write it in a variety of different ways. As a matter of fact, CD, line CD is the same as line BC, which is the same as line, how about BD? And I can change the order as well. Those are all the same. They're all equal to each other. And it's the same thing as line. Let me write out the word line. Line N. It's a lowercase letter without anything on top. Because it's lowercase, we know it's not a point, that it's the name of this line. Okay. Is line CD the same as line DC? It's the same line. Yes, it is. Good. That's the idea. Next word, segment. Segment is part of a line with two end points. There's only one difference between a line and a line segment. Segments have endings. Lines go forever. So we do everything the same except we use 2 points and a segment bar on top. Look at the difference. Here, for a line, I know it's a line because I'm talking about, I have these double arrows on top that tells me it goes on forever. If we talk about a segment, we're talking about part of a line that has an endpoint at the beginning and an endpoint at the end. So, for example, remember how earlier I said line CD goes forever and ever and ever? If I want part of a line, then what I can do is I can write it like this. Let me scoot that up a little bit. This is segment CD. But if you're looking at the picture, you might say, Mr. Paramo, this is a line. It goes forever. I see the arrows over here. Well, guess what? You don't have to. You don't have to just write it as a line. In your mind, you could see that there is a segment that is on that line. We're only talking about this piece of the line, segment CD. Okay? Now, segment CD is the same thing as segment DC. CD is the same thing as segment DC because you can reverse those just like you do with the line. But it is not the same thing. It is not equal to if I have this segment and I go over here and talk about this segment, I don't know if they're the same. It is not the same thing as segment BC. Like, I can't do that with segments, but I can do that with lines. Just so you are aware. Earlier I said these were the same thing. That's because we're talking about a line that goes forever. When we start talking about pieces of a line, the pieces have to be the same pieces in order for them to be equal. Otherwise, they're not equal. Yes?
You probably already said it, but how do you tell the difference between a segment and a line?
There is no difference in the picture. In the picture, there is no difference, but how we write it is how we can tell what we're talking about. Are we talking about a line? Then we need the double arrows.
So can you give me an example of what would be on the test?
The question would be, if I ask for a line that intersects line M, you know what I mean? Like, I might say, give me a line that intersects line M. You can write line N, lowercase. You can write line BC. You can write line CD, but it has to have these arrows on top.
Oh, okay.
And if I said, give me a segment that is collinear, or I'll give you some other words, with EC, you would probably say segment CF or something along those lines, but you have to write it with the bar on top. Chase. Say that again.
If it's BD in a line segment, it's not the same thing as DC, right?
Correct. It's a different segment. That one's a lot longer. Good. Next word. Plane. It's a flat surface that extends forever. It's the two-dimensional equivalent of a line. Lines go forever, but that's one dimension. But now that we have length and width, now we have a two-dimensional thing that goes forever and ever and ever. The way we write them, we use a capital letter. Use a capital letter in the corner. Of the parallelogram. Parallelogram. Man, that's a hard word for me to spell. Or use 3 or more non-linear points. A plane is a flat surface that extends forever. We use the capital letter that's in the corner of like the parallelogram, or we use 3 or more non-linear points. Yep. It's 2, but I'm questioning if that's how we spell it. There's only one R. Yeah, that's my mistake. There we go. 2 L's, 1 R. There we go. My mistake. I looked it up. So a plane, instead of us talking about lines and segments, now we're talking about a flat surface. Think of the ceiling as a plane, except the ceiling is this flat surface, but it has endpoints. It stops when it meets this wall or that wall or that wall. In geometry, a plane goes forever. It goes forever that way, that way, that way, that way. So we have to kind of know, oh, when I talk about plane X, Y, Z, we're not just talking about those 3 points that are up on that front wall in front of you. Plane XYZ is the full thing extended in every single direction. Don't just trap it in that little triangle that we have drawn. So, for example, use a capital in the corner of the parallelogram. When I look at my picture that's over here, is there a capital letter in the corner? How do we write it? We're going to write it like this. I'm going to put, for example, plane, where's the capital letter is? Plane V. If there's a capital letter, and notice there's no point next to it. If it's in the corner of this parallelogram, the parallelogram is going to represent the flat surface, which means that this line here, BD, is in plane V. It means point A is in plane V. We could also use 3 or more non-linear points, meaning not on the same line. So I could also write it as plane, I need 3 points that are not on the line. B, C, D are on the same line, so I need to pick a different letter, a letter that is not on the same line, like A, B, and C. Think of 3 points that can make a triangle. And I'm going to write that here. 3 points that can make a triangle. And I'm just going to draw the triangle picture right there. That's how we write a plane. So, I wrote plane ABC. We could have also said plane ACD. That's the same plane. I could have also said plane ABD. That's the same plane. There's more than one way to write it as long as those 3 points make a triangle. Yep, Lexi.
Can you do ABV?
Since V is the name of the plane and it's not a point, we can't use V. No. V is not a point because it's not next to. A point is a capital letter next to a dot. It's not next to a dot, and it's not next to an intersection of lines. This is the boundary of the plane, by the way. It's not.
If you go outside, you can't do E or F.
Exactly, because those are different plane. Let's talk about array. This is our 5th object in geometry. It's half a segment. It's half segment and half a line. Half segment and half a line. These are like one-way street symbols. I don't know if you've ever been driving and you see a sign on the side of the road that says it's a one-way street. Your parents may have pointed it out to you. Those are rays. A ray looks like this. This is how we write it. We write with the end point first. Write the end point first. So this is how it looks. For example, DC with a ray bar on top. DC. Ray DC in our picture means we're talking about it's called the end point, but really you can think of it as the start point. It starts at D. It has an ending there, but it goes forever through C. That's what that means. So in my picture, we're starting here and going that way. Starting, it's the end point, but that's where it starts, and it goes forever and ever and ever through C that way, down the line. Which means that ray DC is the same thing as ray DB. Because they both have the same start point and they go forever through those other 2 points, but since they go forever, it kind of like matches up. They're the same. But they are not the same, does not equal, is not the same thing as ray CD. If it goes the other direction, starting with C going D, those are not the same rays. They have to be going the same direction, and they have to have the same start point in order for them to be the same. Opposite rays are the last objects we're going to have to know. Opposite rays. Two rays that share the same endpoint and form a line. Two rays that share the same endpoint and form a line. For example, ray CD, notice I'm writing ray CD, the endpoint first, C, then D, and ray, I'm looking at my picture, CD, they have to have the same endpoint and go in opposite directions and form a line. CD, the opposite ray of CD, as I'm looking at this thing, going that way, the opposite ray going in the complete opposite direction is this one. How do we write it? We write it as, I'm hoping this is what you're thinking, ray CB. Is that what you were thinking? Good. Question by Rachel.
Why would it be C?
Why would it be C? I didn't hear the second part.
Why would it be C for the ending?
For the end point. Okay, so let's look at opposite rays. I'm going over here. The definition of an opposite ray means it has a ray going away. They are going in opposite directions. They have the same start point or end. It's called the end point, but it really should be called the start point. It starts at C and it goes forever through D. And the other one that would complete the opposite ray is CB, because if I have those two pieces together, it creates this opposite ray. Creates a line. It's like, think of opposite rays as two rays that have that same endpoint that would create a line together. Jesus.
So another one would be C and E and C and F?
Yes. But here's how you would say it. Ray CE and ray CF. You would be correct if you did it that way. Okay, with the little bar on top with one arrow. Excellent example. So you know what? Let's add that to this. Another example is he said ray CE and ray CF. Good job, Jesus. Those are another pair of opposite rays. Those are the objects that are the basics of geometry. Now there's only 3 new words that I need to teach you as well. You might get these. After these 3 words, we're going to be done with your notes. The first word is collinear. The hard part of learning a new language is learning what all the words mean. That's why Spanish is so hard for me, because I forget my vocabulary words. Collinear means on the same line. For example, point E, point C, and blank are collinear. Point E, point C, and blank are collinear with your partner. Tell your partner which, in your picture, what's collinear with E and C. That's good. I like hearing that. A lot of you get it. It's an easy problem. I heard lots of people say F. Good job. Next word, coplanar. On the same plane. So, for example, what's on the same plane? Let's see. A, B, and C are coplanar with another letter. Point B, point C, and blank are coplanar. What's the other point that goes there? Tell your partner. If you said D, you are correct. Remember, we have to pick a point that is coplanar. Rachel.
Why would there be 4 points and only 3 points with this making?
You can like for example, when I look at the ceiling, A, B, C, and E are coplanar. I could even throw in F and G are coplanar. You can have an infinite number of points that are coplanar. But when we name a plane, all we need is 3 letters that are non-linear, that are not on the same line. Okay? There is a trick question that goes along with coplanar. I need to write this down. I'm going to put a little star. Any 3 points are coplanar. Any 3 points are coplanar. And this is where it gets hard, because I'm going to ask you questions that are not so easy on the pictures. This one will be harder. Let's see if you can figure it out, okay? Here's my example. E, C, D are coplanar. And there's 2 possible answers here. Okay? Point E, point C, and point D are coplanar with. There's 2 possible answers you could put. Look at your picture and see if you and your partner can figure out what are coplanar with E, C, and D. Okay, the correct answer. I didn't hear too many people say both answers, but I'll write them down. B and F. How many of you said B and F? Raise your hand. Oh, I didn't hear it, but 50% of you got it right. Okay. So just so you are aware, let me go back to my picture so you can see. I have E, C, and D. That kind of makes this triangle. And so when I think about this being the flat shape, well, that means that this kind of makes a kite that goes through the plane. It's a vertical piece, whereas this plane here is flat. I see that, and that means that B is coplanar, and I could even go down here to that F, and F has to be coplanar because it's on the same line. Think of those triangles. Think of it. That's the hard one. Those are the hard ones when I go off the graph. There's one other thing I need to write, and I'm just going to add mine to the bottom so I don't have to turn my page over. I'm going to write the word intersections. Intersections. 2 lines intersect at a point. 2 planes intersect at a line. 2 lines intersect at a point, and 2 planes intersect at a line. I'll give you an example. two lines intersect at a point. Let's see. What about line M? Okay, line M and line N. They intersect where? Line M and line N intersect where? Tell your partner. If you said C, you are correct. That's where the lines intersect, at point C. So it's a capital letter. So don't forget, if you're a person who always writes lowercase on everything, or always writes uppercase, in geometry you're going to have to make sure you're intentional and that you're writing your points capital letters every single time. You're writing your lines with two capital letters, which is made up of 2 points with the correct thing on top. So keep that in mind. Two planes intersect in a line. So plane, let's do plane V and plane BED intersect. Plane V and plane BED intersect where? Let me see. If I'm going to go back to my picture. This plane and plane BED intersect in a line. Two planes intersect in a line, so my answer has to be a line. Where does this plane, this triangle plane, intersect with that flat plane? You could say it in 3 different ways at least. I'm going to say in line BD. But if you said line BC or line CD, you are also correct. Rachel?
But BD is a part of the... I'm confused.
Okay. Let me give you a visual about this, okay? If I have the ceiling, and let's talk about the ceiling up here, and I talk about this front wall right here. Where does the ceiling and the front wall touch? It touches all the way down this line right there. Touches all there, right? That's where they intersect. How do we label it? We pick 2 points, like X and Y. It's in both planes. The X and Y is on the ceiling roughly, and XY is on the front wall. Where does it touch? In this line, line XY, there. So where does this plane touch that plane? Right where those 2 lines are. BD is probably the easiest way to write it. Any other questions?
No.
Let's end our notes right there.